Well, good evening once again. Good day, everyone. So, welcome back to the next episode of the video. Here we want to look at how we calculate battery size. We have done the load analysis. We have done the battery voltage selection. Now, how do we calculate the battery size? Now, before you can successfully calculate the battery size, there are some points you need to note. Number one of that note is when you must be able to decide the days of autonomy. Now, what do I mean by days of autonomy that you need to decide when you are trying to design a solar system is number one. How many days do you want your solar system to run without interference? That is, without tripping off, even when there is no sun radiation and there's no means to charge the system. You want the system to operate autonomously. So that is number one, days of autonomy. You must decide. Now, we have recommendations. If the system is an off-grid system, we always recommend at least 3 days of autonomy. So for off-grid system, by now I believe everybody will know the meaning of off-grid. For off-grid system, 3 days of autonomy is recommended. Now, for on-grid system, for on-grid or for grid connected, for grid connected system, 1 day of autonomy is acceptable. It is assumed that at least no matter what, within 24 hours there will be power supply from the power generating company. That is thus the reason why we choose 1 day of autonomy. But if the system is a off day, there is no way within 3 days there will be sunshine to replenish the battery usage. Then another point that is worth note that we must take note of is point number 2 is the depth of discharge of the battery. The depth of discharge, DOD, depth of discharge. Now, if you are using a lead acid battery is also called a flood battery, right? So lead acid battery, the depth of discharge is for lead acid battery, we can use 50% DOD. We cannot run lead acid battery more than 50%. Then the efficiency of lead acid battery is around 80%. The efficiency is 80%. That is the energy conversion efficiency. That is the amount of chemical energy that is stored that can be converted to electrical energy and vice versa. That is just the efficiency of the system. So if you are using a lithium battery, for lithium battery we use a 80% depth of discharge, DOD, 80% or 70% as the case might be. Then efficiency is equal to 90%. That's for lithium battery, 90%. So, having taken note of these 2 points, I think we can now talk about the process of calculating the battery size. So, how do we do that? Let's take the value we got from the earlier stage of the work, which is we got the total load to be what? 1630 watts, and we want the system. So battery size now. So how do we, the power that we calculated from the load analysis, that is from step 1, which is 1630 watt hour, then multiply by 3 days of autonomy. by 3 days of autonomy M multiply by. Now when you said we had the calculation, I want to do the calculation based on the, let's say based on the lead acid now. Lead acid, for lead acid, for lead acid battery now. So for lead acid battery, so remember we said the lead acid battery, the depth of discharge is 50%. So which means when you want to charge lead acid battery, you're actually charging it half. You are only charging half of the total storage. So which means you now multiply it by 2. So multiply by 2. Then the efficiency is 80%, right? Then we multiply by the conversion efficiency, which is a 1.25. You have to make provision for excess load, because you know when you are designing for anything in electrical engineering, we always talk about diversity factors. If the total power you calculated is 1000 watt, you have to multiply that 1000 watt by certain percentage. We call it diversity factor, DF, so that in case someone just overloaded the system by certain amount, it shouldn't cause a problem. So 1 point multiply by 2 multiply by 1.25, that's 125%. That is, when the system is loaded to 125% of the system, there shouldn't be a problem. So let's calculate everything we've gotten from here. So 1630 multiply by 3 multiply by 2 multiply by 1.25, everything will give us 12,225 watt hour. 12,225 watt hour. 160 watt hour times 3 days. Let me multiply by 2 multiply by 1.25. Okay, so this one gives us 12,225 watt hour. So, and remember our battery voltage is what? And the next thing is divide by the battery voltage. All the batteries that we have around there are just 12 volt batteries. This battery voltage is different from what we calculated from the second stage rather. No, we said from our choice, from the calculation we did, I did tell you that we are going to use 24 volt system. Now I want to make use of 12 volts. Now it means we are going to be using more than one battery. So we'll be connecting 2 of that 12 volt battery to make it up to 24 volt system. We'll connect them in a series. Okay, so the battery divided by the battery voltage, which is 12 volt, because we want to calculate the size of each battery. So we now have 1,225 12,225 watt hour divided by 12 volt. So now will give us let's see what we are going to get from there, which is 12,000 divided by 12. That will be 1,018. See, 1,018.75 amps hour. Remember, if watt is a VA, that is volt multiplied by amps, then there we have 12 volt. So the 12 volt under will cancel 1 volt here, so it will be amps hour. So we'll be left with a amps hour. So 1,075, which is approximately equal to 1098 amps hour. That is if we want to use a lead acid battery. Let's assume we want to use lithium batteries. For lithium batteries now, so remember what we said, depth of discharge is 80%, efficiency is 99%. So 1630 watt hour multiplied by 3 days of autonomy, we assume that we are using off-grid system, multiply by 1.25 multiply by 1. So now what we are saying is, now you discover that the 2 that we used to multiply this one, because the depth of discharge of this one is 50%, so this one is almost 100% discharge. Depth of discharge is almost 100%. We assume that we are discharging it totally, so it has to charge it from beginning. That is why we are using it to multiply 1. 1 represents 100%, so this one will give us, let's see what we get from there. 1630 multiply by 3 multiply by 1.25 multiply by 1, so this one will be 6112.5, which is going to give us 6112.5, which is approximately 6113 watt hour. 6112 watt hour. 611, let me check the value. 6112. So divided by what? Divide by 12 volt. Divide by 12 volt. So which will now give us, divided by 12, that would be 509, which is around 510. 509.37 509.37 volts. That's a amps hour. So when you look at the two values we have gotten, when we use a lead acid, we arrived at the battery size of 1098. When we use a lithium battery, we arrive at a battery size of 590. So you discover that using lithium battery, we use lithium battery requires smaller battery size for the same amount of load. That's to tell you that the efficiency of lithium battery is far better than the efficiency of lead acid battery. That will be all in this. So let's take note of the values we have gotten in the different calculations we have done so far. So in the next session we are going to continue. We have done the battery size calculation. Then the next thing is to find your sun hour. So in the next video I'm going to be explaining how we can achieve that. Thank you very much for watching this video. Please like, subscribe, download, share, comment. We'll be so glad to welcome your contributions, both positives and negative. Thank you very much. I remain myself, Engineer Clemens, from the Department of Electrical Engineering.